All right, so 8.6 is kind of a review of conic sections, so what you've done so far. Which is good since you've had your week-long spring break. All right, so standard form for the conic sections with center HK. So these are all equations that you've seen before. We've talked about the circle, ellipse, hyperbola, and parabola. Okay. So in these examples, we're going to identify the conic section that each equation represents, and then we're going to find HK. So for the circle, the ellipse, and the hyperbola, HK is called the center, right? But for the parabola, what's HK? Yeah, the vertex. Great. So make sure that you know what you're finding when you find HK. All right, so number one, I have x plus 4 equals y minus 2 squared all over 10. So can you guys tell what that is? It is parabola. The parabola is the only one, if you go through and look at your equations, it's the only one that doesn't have both x squared and y squared. It only has one of them. So notice how like the horizontal one has y squared, so y minus k squared, and the vertical one has x squared, but they don't have both of those. Okay, so it's the only one. All right, so this is a parabola. All right, and then the HK, like I said, is called your vertex for a parabola. So your vertex, it's always x minus h and y minus k. So h is -4 and k is 2. So it's always like the opposite sign. I think in your notes before I had you guys, this equation had the h over here, like plus h, but this is usually the way I like to see them. So it's always x minus h, y minus k on all your formulas. All right, let's talk a little bit more about this parabola. Does it open right or left or up or down? Which of the following? It opens right. How'd you get that?
It's x equals, and it's like positive y
Exactly, good. So since it's x equals y squared, those are parabolas that open horizontally. And since your number in front of your y squared part is positive, it's 1/10, right? 1 over 10. That means that you, since positive, it opens to the right. If it was negative, it opens to the left. Good. All right, how about number 2? What's that? Yep, it's a circle. So I'll draw that on the right. Okay, so it's a circle. And then the things I like to know about a circle are the center and the radius. So the center is HK. So what's my center?
0, 4.
Yep.
Oh, yeah,
Yep, it's 0, 4. You're right. And then the radius? Yeah, guess I'll take a little break. You forgot all this? 10, right. Because it's r squared. Are you laughing because you did? All right. So next step. So this one's not really in one of those forms. Like if you look at your chart, it doesn't really look like any of those right now. I know that it does have x squared and y squared. So it's not going to be a parabola. That's out. But it could be an ellipse, a circle, or a hyperbola. So let's try to get it in one of those forms. So the first thing I'm going to do is I'm going to take this 9 times y minus 2 squared, and I'm going to bring that over to the left side of the equation. So I'm going to subtract it over. Okay, at this point right here, I can tell what it is. Can anybody else tell what it is?
Hyperbola.
Yeah, it's going to be hyperbola. So Raja, why do you say it's hyperbola?
Because you can divide out at 16.
Yeah, you could divide by like 144 on both sides, or you could you're saying divide by 16. The hyperbola is always equal to 1 at the end. Like that's the form you want to try to get it to. But there's something like the circle and the ellipse. Notice on the circle and ellipse equations. See how they have this? It's always plus. Notice how the hyperbola is the something squared minus the other something squared. That's how right away I know it's hyperbola. Okay, so let's try to get it in that form. So I'm going to divide by 144 on both sides. So if I had 16 and then 144 on the bottom, that actually reduces. So you don't have to write this step here, but I like to write that step because then I see 16 and 144. They're both divisible by 16. So I'd get 1 and I'd get 9. And the reason I'm doing that is because in your formula, notice how you don't have like a number here. You don't have any numbers right there. So we want to divide, like simplify your numbers as much as possible. Okay, so same thing here. If I do 9 over 144, you can always do that on your calculator, 9 divided by 144, and then switch it to a fraction. You'd see it's 1 over 16. That would help you reduce. Or you can do 144 divided by 9, it's 16. So that means my formula is x minus 1 squared over 9 minus y minus 2 squared over 16 equals 1. Okay, so that's my equation. Okay, so like I said, it's a hyperbola. Okay, and since it's been a while since we've seen these things, let's kind of talk about the hyperbola. Okay, there's two choices. It can be horizontal like that, or it can be vertical. That's a terrible one, like that. So which one is it going to be, horizontal or vertical? Yeah, it's horizontal because it starts with the x. Whatever variable's first, you're going to go along that axis, I guess. I don't know the best way to describe that. Remember, I always said I remembered that it looked like an x, but it doesn't look like an x because these ones look like an x too. I don't know why that worked for me. Okay. Let's see. So it's a hyperbola. It's horizontal. For a hyperbola, the a squared is always first. So a is 9, or a squared is 9. So a is 3. So that's a squared. The other one is b squared. So b is 4. Okay, and it's good to know this, like for either an ellipse or a hyperbola. If you have the number under the x value, that's telling you how far you're going right and left, like from your center. So that means we'd go right and left 3. And then the number that was under my y value, that's telling you up and down. So you go up and down 4. And that allows you to draw in that little box. You guys remember our little box from my hyperbola. Okay. So this next one, so let's try to get it in that same form. So how about you guys try this one? I'll give you a couple minutes to try it. Okay, I think most of you guys are seeing it's kind of tricky. So how many of you guys think that it's a hyperbola? How many of you think it's a circle? How about an ellipse? And parabola? Okay, so let's see. All right, so I'm going to add my 16 to the other side, or well, the whole 16 term. So I'd have 16x minus 1 squared plus 16 times y minus 2 squared equals 81. Okay, so at this point you're like, oh, I know there's a plus sign. So it's x squared plus y squared something. All right, so that means that I'm either going to have a circle or an ellipse. So that's what I'm down to. All right, so if I divide by 81, which is I think the route that most of you guys were going as I walked around, you guys have something weird. You have like 16 over 81 x minus 1 squared plus 16 over 81 y minus 2 squared equals 1. And when it's in that setup, it looks like an ellipse. Like you have it equal to 1. You have denominators. But we never had these numbers out front for an ellipse. So that's where it gets a little tricky. Like you would have divided by a weird fraction. So, I mean, it works out. It could be an ellipse. But what else do you notice about the 16 and 81? Yeah, Elaine?
You can pull the 16 out to the front and then divide.
Yeah, you could do that. So it would look like in the end, you'd have like 81 over 16 on the bottom for your numbers. Yep, you could do that. But what about those numbers now? What's A, what's B? They're both 9 over 4. So if they're both 9 over 4, is it an ellipse? So that means you're going right and left the same amount that you're going up and down. So what is it? It's a circle. So that's what's tricky about those. So if you see that these numbers are the same, then you're not going to try to solve to make it an ellipse. If those are the same, you're going to try to get it into the circle formula. So you might want to write yourself a note like same number means circle. I guess I should say and plus sign, like you need to have the plus sign. So plus sign. minus, that's a hyperbola, because the A and B for hyperbola can be the same thing. They don't have to be different. Okay, so I know I'm going to have a circle. So it's almost looking like a circle, except I need x minus h squared plus y minus k squared equals r squared. So I don't need these numbers out front. So now I'm going to divide by 16. So I'm going to have x minus 1 squared plus y minus 2 squared equals 81 over 16. And that doesn't actually reduce. Okay, so it's a circle. My center is my HK, so it's 1, 2. And my radius, you guys said it earlier, what was it? When we had it set up as an ellipse, you guys said A and B were both 9 over 4, right? That's what your radius is. Okay, so a circle is an ellipse. It's just an ellipse that has A equal to B. Okay. Next step. Okay, so it says if you're given an equation in standard form, so like what we just had, you know, what we solved for, you can get it in what we call general form, which is multiplying everything out. So basically, if you started with something that looked like what we just found, what I'm underlining in blue, you could FOIL all those things out. You'd have an x squared term, a y squared. You'd have something with x, something with y, you know. That would, and you can make it in general form, or yeah, this general form here. Okay, kind of long. But the convenience of doing that is you can use this chart that's going to tell you what kind of conic section you have, if you have a parabola, a circle, ellipse, or hyperbola. All right, so all you really need to know is once you multiply it out is what A and C are. So A is the number in front of x squared, C is the number in front of y squared. So let's go through these different things and determine what A and C are, and then we're going to use this chart to decide what kind of conic section we have. All right, so A is the number in front of x squared, C is the number in front of y squared. So since I have 3y squared, if you look at your long equation up here, that's your C. So A is 3, or sorry, C is 3. Because I had 3y squared and I have cy squared up there. All right, now I have negative 1x squared. So that's telling me A is negative 1. And you could go further and you could find all the other variables. Like you see how F is just the plain number. There's no x or y or anything. So F would be negative 9. But what I'm telling you is all you need to know are A and C. You don't need to know all the other ones. Okay, so based on our chart, is it a parabola? So A equals 0 or C equals 0, but not both. Nope, not that. Is it a circle? A equals C? Nope. Is it an ellipse? A and C have the same sign and A is not equal to C? No, they're not the same sign, they're opposite signs. And then hyperbola, A and C have opposite signs. Yep, that's what it is. So it's a hyperbola. Notice that A did not have to not be C. No. A could have been equal to C in that. All right, B. So I have 2x squared, 2y squared. So in front of the x squared is my A. In front of the y squared is my C. So what do I have? Circle. All right, and C. So A is 0. C is 1. So what's this? Parabola. And that goes back to the thing where we said it has y squared, but it doesn't have x squared. So it only has one of them.